Have a video of instruction today for you that goes along with your book on lesson 7.5, which is about solving special types of linear systems. And the first couple of things we will do is draw your attention to the vocabulary word inconsistent system and consistent dependent system. If you will get ready to take notes, please, we'll jump to the next page here and see what I'd like you to write down. Please write down lesson 7.5 is about solving special types of linear systems. And the first thing we want to do is to define what is an inconsistent system. And an inconsistent system is a system of linear equations that has no solution. And we'll add some more notes to that below that, so give yourself a little room to write some extra there. And then we'll also define for you what is a consistent dependent system, and that is a system of linear equations or of equations that has infinitely many solutions. And we will add briefly to that too, so give yourself a little more room. I'm going to move to a new slide here, and don't worry about graphing anything. I've put a graph on here to show you something in a minute, but what we can look at now is up here in example 1. We need to get these copied down so we can start working with them. If you see them stacked in your book, right now our equal signs are not lined up, our x's are not lined up, our y's are not lined up. We can't do anything to solve that real quickly. So as we start working, we're going to want to copy the equations down again, not stacked, so write them out next to each other. And we have that y equals 2x minus 3. If we take the second equation and we subtract 2x from both sides, we will be changing that into standard form. We'll have negative 2x plus y equals 3. Actually equals negative 3. And now we would be to the point where we would look at that and say, let's double that. And actually, as we double it, let's not just double it, let's multiply the entire equation times negative 2. That way, when we go through and multiply each term in this by negative 2, we get a positive 4x. And now if we add those together, it would eliminate the x. And we will also get a negative 2y, and we will get a positive 6 here. So if we add these together now, we get 0x, and we also get 0y. So what's left on the left side of the equal signs really is 0. If we bring the equal sign down, now the 8x plus the 6 gives us 14. 0 does not equal 14. So since this is a false statement, this is a situation where our two equations have no solution. And if they have no solution, we would call this a inconsistent system. And kind of the reason why I have the graph there, as I said, don't worry about writing anything down. But if I were to take a look at the graph of the two things, you'd notice this equation is already written in slope-intercept form, where we have a y-intercept of negative 3. And if I plot my y-intercept of negative 3, we have a slope of 2. And I build a slope of 2 from here, which would be to go up 2 over 1. And we can get another point. And if I keep doing that, I can keep getting more points to accurately draw a line in here. And if I draw this line in here, that would be the second equation. If we now take a look at the first equation, I have options. I could change that into slope-intercept form in order to graph it. I already reviewed with you how to graph 1 by slope-intercept. I would like to review with you that if we make x equal to 0, we put the 0 in for x, we're going to wipe that part of the equation out, and we'd be left with an equation that says 2y equals 8. So I could divide by 2 on both sides and find out y is 4. And if y is 4, that's on the y-axis, we get 4. If I now were to put in y is equal to 0, and I put the 0 in for y, I get negative 4x equals 8. And if I divide by the negative 4 on both sides, I get that x is negative 2. And now I've found the x-intercept, which would be right there. And if we draw the line that crosses these 2 points, we should see we have 2 parallel lines. And if we have 2 parallel lines, the lines will never intercept, so that our system of equations has no solution. If we jump back to the first slide, then I would like you to add to your notes about what is an inconsistent system. It's a system without any solution, but it's also where the graphs would not intercept each other or intersect. So we got one example done, showed you what inconsistent systems look like and what that'll look like when you solve the system. And now we'll take a look at inconsistent systems and what that'll look like when you solve those. If we look at these, once again, our x's and y's line up this time, but if we look at what the coefficients are, they don't eliminate each other. So we need to do something to these before we try to eliminate these. So for example 2, once again, copy these down. 4x minus 2y equals 8, and negative 2x plus y equals negative 4. And this one, how about if we take the second equation and double it again? So if we multiply this side times 2, our 2 times our negative 2x, our 2 times our y, and our 2 times the 8 will give us the new equation, negative 4x plus 2y equals negative 8. And if we add these together, hey, there we go. We eliminated the x's. We got 0 there. Next to it, the negative 2y and the plus 2y, we got 0 again here. We've eliminated the y variables. So on the left side of our equations, we have 0. We bring down our equal sign. 8 plus negative 8, we got 0 on this side too. That turns out to be a true statement. So since that's true, this is the situation where it has infinitely many solutions. And if it's got infinitely many solutions, that is where we're going to call this a consistent dependent system. What's got to happen in order for you to have a consistent dependent solution? Since the equations that we have here are both in slope-intercept form, if we go back and we were to graph these again by using our intercepts, if we put a 0 in there, we get negative 2y equals 8. We divide by the negative 2. We'll find out that y's intercept is at negative 4. We can plot that over here. Remember, you don't have to include the graphs in your notes, but you should have the examples written out. If we put the 0 in for y, we are going to get 4x is equal to 8. So if we divide by 4 and divide by 4, we'll find out that x equals 2. So if we go to x equals 2, there is our graph of the first equation. And if we now were to do that for the other equation, if we put a 0 in for x, we would get the equation y equals negative 4, which is this point. And if we put the 0 in for y, we will get the equation of negative 2 equals negative 4. Divide both sides by negative 2, and we will get that x equals 2. And we get that for our x-intercept. And if we go to graph this, we have one line that falls right on top of the other line. So we actually have every point on this graph is a solution. That's where you're getting infinitely many. So if we'll jump back to that first slide, what will the graphs look like in a consistent dependent system? It will be that one graph falls right on top of the other graph. And every point on each line or on the line gives you a solution. That should be enough that you'll be able to work on your assignment that you'll see tomorrow.